The trapezoidal rule is equal to the integral of f of x dx from a to b, where t and the trapezoidal rule is equal to delta x over 2 times f of x of 0 plus 2 f of x of 1 plus 2 f of x of 2, and so on until you add 2 f of x n minus 1 plus f x of n, where delta x is equal to b minus a over n.
As you can see, f of x of 0 and f of x of n have no coefficients in front of them. However, all the x values in between have 2 as the coefficients.
One thing to remember is that the trapezoid rule is not exact, so it is actually an estimate of the value of the area of whatever you're trying to find. So one thing to remember is that n is the number of subsections between a and b. N has to be an even integer, and it has to be positive.
X power of 3 of dx integral of 2 to 10 is equal n equals by 4.
So delta x is equals to 10 minus 2 over 4. It's also equivalent to 2. So in the number line from 2 to 10, right, 2 to 10, there's 3 different lines, which is 2, 4, 6, 8, right? 8. This is x0, x1, x2, x3, x4.
So we take the 2 and place it into the formula. This makes 2 divided by 2 times 2 cubed plus 2 times 4 cubed, and so on until 10 cubed. When we calculate, we get 2,592.
If we derive directly using power rule, we get x to the power of 4 divided by 4 from 2 to 10. This is equal to 10 to the power of 4 divided by 4 minus 2 to the power of 4 divided by 4. This is equal to 2,500 minus 4, or 2,496.
Our second problem is x squared dx from 1 to 2, and then n is equal to 2. First we need to find the change in x, which is equal to 2 minus 1 over 2, which is equal to 1/2. Then we're going to plot it on a line graph from 1 to 2, and the middle would be 1.5, and that makes x of 1, x of 0, x of 1, and x of 2.
Then we take our delta x and plug it back into the formula. We get half over 2 times f of x of 0 plus 2 times f of x of 1 plus f of x of 2. This is half divided by 2 times 1 plus 2 times 1.5 squared plus 2 squared. This is equal to 19 divided by 8, or 2.375.
So if we were to integrate the problem with the power rule from 1 to 2, x squared, we would get x cubed over 3 from 1 to 2. This is the same thing as 2 cubed over 3 minus 1 over 3, which is also equal to 2.6 minus 0.3, which is also 2.3.
Our third problem is 1 over x integral from 6 to 12. N is equal to 6. First thing to do is to find the change in x, which is 12 minus 6 divided by 6. This equals 1. This means that 6 is x of 0, 7 is x of 1, all the way up to 12, which is x of 6. When we plug the 1 into the formula and the x values into their respective spots, we get 0.69. If we integrate the problem, we know that 1 over x is equal to ln of x from 6 to 12. This is equal to 2.5 minus 1.8, which is also equal to 0.7.